Hi guys, uh, my name is Amit and today we are going to solve this first question of our mechanics of material course. Actually I am following my teacher. Last year this I done from home, so I am going to solve all the questions, making a solution video for all of the questions, and it's really important for all of us. So the chapter is 1 and we have to find the internal forces, and this is the first question of the assignment. So we have a first question, this first list, analyze the question. We have to find the internal forces for section C. So here let's analyze the question first. This is the section, right? So we have to find the internal forces. So first we have to know what are the internal forces. Suppose we have a beam over here or a bar, and maybe we have some kind of section over here. So if we cut this section, generally we have three kind of internal forces. In order to understand, I put it like this. One is N is normal force. B means shear force, and M means bending moment. I would like to request you to have a look of this, because these things is very important in all the chapters, coming all the chapters. So this is a bar. We cut this section here. We have a cut over here. So let's. So this is a bar. We have a cut over here. So this is a bar. Okay, let me make it like this one. So this is a bar A and B to understand internal forces. Here we are understanding the internal forces. So N and P. In order to understand, we can N and B. In order to understand, we can N and B is the internal forces. So now, in order to find internal forces, what we can do is either we can take left hand side or either we can take right hand side. Suppose if we take left hand side, suppose I write here left hand side and here I write right hand side. Okay. So if I take the suppose take this point as C. Okay. And suppose if I take this point, this A point and the left hand side, so that will be like this, right? Like this, A and this point C. So if we cut this section, so we have three forces over here. So if it's on the left, so you can remember on the left the B force is downward. This is the shear force. And since this is a normal force means actually the reaction. If we cut this section, right? If we cut this section, so it has tendency to like this, right? Like it is a reaction forces. So if we cut this section, the normal force will be like this. And about the moment, since we cut the left hand side, so the moment will be like this. So the moment will be here. Our moment will be like this. Moment. Like this. So you have to understand this thing. If you take a left hand, opposite of it, if we take a right hand side over here, same thing. So we take analyze C and B. So if we take C and B, suppose we are taking here C and B. So this is B, this is C. Similarly, here is three forces. For sure, here will be also three forces, right? But here the shear force is downward. Since it is a left, so left means shear force downward. On the right side, the shear force is upward, like this. V. Here you see. And normal forces is the reaction forces. Where we cut, there is a normal force, right? So normal force will be here. That is N. My writing is not good, so please don't mind. And since it is the right side, so the moment will be like this. The moment will be like this. So the moment will be, bending moment will be like this. In further classes, you will going to understand all those things in a depth. But this is the first chapter, so you can understand those things. If you understand those things, then you can do this question. So you understand what is the internal forces, no need to go in depth. For internal forces, NMB, normal force, bending moment, and shear force. NMB, you just have to remember there are three forces when we cut a section, and this is a section where we are cutting. Now we have to find out internal forces on this section, C, right? So let's erase this one and now make our solution of this question. Should I use another chalk? I think the red one is okay. So since this is a question we have to find the internal forces through a section C. So first step, what you need to do is you need to make a FBD. FBD means free body diagram. What you studied in theoretical mechanics. I will also make a video about the theoretical mechanics, all the questions, and to make you understand. So this is a UDL. So let's also have a concept of this one. Suppose this is a maybe bar or a beam. We have a support kind of this thing, right? And suppose we have this one. This is a UDL. This is called UDL, uniformly distributed load. UDL. And suppose it has a P kilonewton. It has a P. This is a P kilonewton per meter. P kilonewton per meter. It has a moment P kilonewton per meter, and it has a length of x. So this is since this is a UDL, we have to find the point load. So there is a formula. Just remember the formula. Formula is point load equals to P into x. P into x. So if we make a P into x, if we make this one, so A and B, it will be like this. So since the point load is Px, we just multiply. So Px will occur somewhere there. So in order where it will occur, in order to understand that, we have to find POA. So for this UL, POA is point of application, is always x by 2. So since the distance is x, so from here to here, at a point here, x by 2, here will be our Px. So this is called UDL. So you have to remember these two formula, and you have to remember this one. We use this one method over here, right? So this is a UDL. We have a point load. Since we have a 20 kilonewton, so it's a UDL. We have to find a point load over here, like this way. So you note this one. You will need this thing in further more classes. So let's erase this one, and now let's go to solve that. I am making you understand full the thing. Like suppose you know the internal forces, you know the UDL, and then you have to understand all those things. Then you're gonna solve it, right? So I'm trying to make you understand all the concepts in a video. So it's a long, but if you watch this till at the end, you will understand the whole concept of this. Okay. So I hope you note these things. Now let's take another chalk. Yeah. I just check the video is looking or not. Yeah. Now we have to solve the solution. So let's make a free body diagram. This is a beam. So we can take a line over here. Yeah. Beam. This is a beam. Since this is point A, this is point B. There is no any point. So we can take a left in. So this is a roll-on support, right? For the supports and types of beam, you have already studied in theoretical mechanics. That is called a roll-on support. That is called fixed pin support. So on fixed pin support, we have two reaction forces, right? One is VB, and what we can take another one is HB. Since there are no any other horizontal forces, you see there are no any horizontal forces, so HB equals to 0, right? Yes. And we have a beam like this. We can also make like this, and this is the point you can see. It's near here. And this is a roll support, right? So roll support, it can't move. It can't move vertically, right? So it is constrained. It is restricted to move vertical, right? So the boundary condition will be BA, Understanding? Yeah. B. Since it can move upward, right? So it can't move upward. It can only rotor support only go from horizontal like this and like this. So that's why we take VA, and here it's a pin support, right? It can only rotate, right? Suppose it's a pin, and if like suppose this is a pin and it's rotate like this, so it can only rotate. It can't move right, it can't move up. So that's why DP and DB. There is a support reactions, right? Yeah. And since we have a UDL over here, I already told you, since we have a UDL over 20 km, so what's the formula to find the point load? We have to find the point load, right? Point load. Point load. What is the point load? My writing is not that much good, so I can write PL, point load. Simply, what is PL there? 20 km into 2. 20 into 2. What is it taken? 40 kN. Since it's a moment, and we find the force, right? And this is a distance. So 20 into 40 kN. So we have somewhere here 40 kN. That is a force. What? That is called a force. And since we have also find the POA, this is the point of application. What is that? X by 2, right? So what is X here? X is 2, and X by 2, 2 by 2 equals to 1 meter. So the half of will be here from here to here. That is 1 meter, right? And from here to here is already given in the question. That is 2 meter. So we find this one. We find this one. Now, yeah. Now let's put also the distance over here. From here to here. Let's put C which here. Yeah. So from here to here it's also 2. From here to here it's also 2. Since this is the first step to make a FBD. Now then the second step is to find the support reaction in any question. If you go in the mechanics of material in any question, the first always step is to understand the question and make a free body diagram of it, and then to understand the support reaction in every question of this mechanics of material. The first step is to free body, second step to support reaction, and then you find here what in the question says internal forces, or maybe another thing, stress, strain, another thing what the question said, you have to find this. So second step is to find the support reaction. What are the support reaction over here? This is the support reaction. Since this is a support, what kind of support is? It's fixed pin support, this is a roller support. So this is one support, this is two support, this is another support. Since there are no any horizontal forces, right? So we don't have to find this one. SB equals to 0. So we don't have to find that one. So we have to find only two forces. One is here, one is here. And this point is A, this point is, this point is B. So you see we have to find VA and VB, right? So there are three equilibrium conditions, right? What we study in the theoretical mechanics. That is, that is, one is moment equals to 0, sum of moment equals to 0, sum of forces in y direction equals to 0, sum of forces in x direction equals to 0. So this is the three standard equilibrium conditions. I think we can note this one. Equilibrium conditions. We have to note this one. This is the most important thing for to find the support reaction, which you need in most of the question. This one things. So we have to use this one to find the VA and VB. So let's use it. Okay. Let's use it. Some of you guys think it's really easy, right? Yeah, but for some of the students it's really difficult. Like suppose you didn't study anything in the critical mechanics, and you have to find everything. You have to understand everything. So that's why I'm making a video in a depth to also make also make a student understand who didn't study theoretical mechanics. So I'm making a video like that way, right? So we see the three equilibrium conditions, right? Since we have a VA and VB, we have a point load over there. If we take a f of y, so VA and VB will be the same one. So let's take a f of y over here to find the support reaction. F of y. There is no horizontal forces, so SB equals to 0, which I told you. Why SB equals to 0? Okay. If you have any concern why SB equals to 0, let's take f of x equals to 0. Since there are only one HB, right? Since there is only HP, right? There is only one HP, and also I will also like to tell you one thing. I'm taking this one as like this one. This is plus x. This is on the coordinates. This is plus 1 here, minus here, minus. And for the moment, I'm taking this. For the moment, this is a clockwise. This is a anti-clockwise. This is anti-clockwise. For the anti-clockwise, I am taking plus. For the clockwise, I am taking minus. So you have to understand this one. For the what is a clockwise? Clockwise means this. Clockwise means this. So clockwise minus, anti-clockwise plus. So we will take, in order to find the moment, we will take this one, clockwise, anti-clockwise, and for the coordinate system, to find the support reaction SB, BA, we need to use this one. We also need this one to find the internal forces and the bending moment. So you must have to know this one. We are going to use this one. Note this one. I am going to erase this one. Yeah. Okay. Since you know the coordinate system, right? I'm telling you why here SB equals to 0, right? Since f of x equals to 0, there are no any horizontal forces, right? So if we take, here is minus SB, right? I take the direction like this one. So here on that side plus, on that side minus. So here will be minus SB. Since there are no any things, so plus 0 equals to 0. Right? There are no any other horizontal forces, right? So since SB equals to 0, there you see, we find SB equals to 0. When you make a lot of questions, then you just directly understand. You don't have to do these forces in the fx direction and then you calculate the SB. You can do directly by analyzing the figure. First, you have to make a lot of practice. You have to do a lot of practice, and then you have to do a lot of questions. Right? So let's do f of y. Since what we take, like on the coordinate system, what I told you, right? Like this. If this is plus y, upward direction. This is plus y. So since this is plus y, if it's going down, this is minus y, right? So if we take the follicular, this is minus, right? Minus 14. This is plus b, right? What is this? This is also plus. That is bb. What is that? Equals to 0. We got the equation. What we got? ba plus bb equals to 0. Let's take it as equation 1. So I mean not 0. So this is minus. Sorry, this is minus 14. This is, I mean, sorry, not minus 14, this is plus 14, this is minus 0 there, that will be plus 14. So since, let's take it this one. Since if we take this one as a first, we have BA plus BB equals to 14, right? Which is like, it's impossible to like directly find BA plus BB. So we need to use a moment. So where should we take a moment? Here. It's your choice. Either you can take a moment over here. Either you can take a moment over here. What I always recommend, always take a moment where two forces or more than two forces will cancel out. Since if you take a moment over here, right, there is only one forces which will be cancelled out. Also there is SB equals to 0, but in other questions where horizontal and vertical force both are given, so I always recommend to take the moment at a point where there are more than a force. Here since there are two forces, so let's take a moment at this point B. Okay, so let's take a moment at and B. Summation of and B equals to 0, right? Since we take a moment at B, then this one and this one will be cancelled out. Why this will be cancelled out? So we have to understand what is a moment, right? So if you don't know what is a moment, moment equals to force into perpendicular distance. So this is a moment. Right? So there should be perpendicular distance. So if you take a moment around B, right, there is no any perpendicular distance, right? There is a force, right? But there is no any perpendicular distance when you take a moment at B. So that's why this one and this one we should not take, right? Okay. Now, if you take a moment around B, this will not count it because they don't have any perpendicular distance. Since if you take a moment around B, this one will go over here, right? So from here, right? If you take this one, so since you see, I told you, right? This is going this one, right? What is this one? This is clockwise, right? So for the clockwise, what we take? This is a clockwise, right? So for the clockwise, what we take? Minus. So this is minus VA, right? This is minus VA, right? This is clockwise going towards B. Since we are finding the moment and it's going towards B, it's a clockwise, right? So that will be minus VA. Minus VA. And now perpendicular distance. What is the perpendicular distance? Since we are finding from 2 to, what is that? 4. VA into 4. Okay. Since now, if you see this 40 kilonewton point load is going like this, right? It's going like this. What is this? This is anti-clockwise. It's coming like this, right? So it's anti-clockwise. See, it's anti-clockwise. So for anti-clockwise, what we take? Positive, right? Plus 40 kilonewton. Plus 40. And yeah, it's a kilonewton. Okay. I thought it's a newton. No, it's a kilonewton. No problem. So we can take it. No need to convert it into 10 to power 3. We get force into kilonewton, no problem. Okay. Since this was what the distance? It's a perpendicular distance, right? From here to here, it's a perpendicular distance. From here to here, it's a perpendicular distance, right? So from here, 1, 2 to 4, 1, 5 into 5 equals to 0. Since we can find easily we can find VA from here, right? So what will be the VA? If it have go over here, 40 into 5, right? This will go over here, divide 4 over here, and that will be here VA. Since this is 4, this is 40, 10. So what is the VA? VA equals to 50 kilonewton. 50 kilonewton. VA equals to, we got 50 kilonewton. Since VA equals to 50 kilonewton, it's a positive, right? Since we take a positive over here, so this is okay. What if in case this is VA equals to minus 40, minus 50? Then we have to change the direction of a VA. For example, we got VA equals to 40. We take a VB as upward, right? So let's find VB, then you will understand, right? So we find VA equals to 50 kilonewton. Let's take, yeah. We find VA equals to 50 kilonewton. Then let's find VA. We have the equation over here, right? Okay. So if we take VA we got the value over here, right? Plus 50 kilonewton plus VB equals to 40. Since we have to find VB, so VB equals to 40 minus 50. What is this? We got VB equals to, see, we got VB equals to minus 10 kilonewton. Since where is it? VB equals to, we get minus 10 kilonewton. So we have a VB. Since we take this direction as a positive, but it's come into negative, see, minus 10 kilonewton. So we have to change the direction of this one. We have to change the direction of this one as downward. As downward. So this is P. What we get? VB equals to 10 kilonewton. Since we get the minus, so we have to change the direction. Since we suppose this is upward, but at the end we also get upward, no need to change direction. But here we suppose this force is upward, but this force come downward, so we change the direction of that force. What we get here? A equals to 50 kilonewton. So what we gonna do here now? We have the forces over here. We find the VA and D. We will just write it. We will just erase this. Now third stage is to find internal forces. Third stage. Okay. Then we find the internal forces over here. Write it again. So DA, we got DA equals to 50 kilonewton. Yeah, suppose I'm writing it over here. This is A, this PA equals to meter. How much we got? 50 kilonewton. And VB we got 10 kilonewton. Since we got VB, VA, we have this one. Now we have to find the internal forces at this point. Let me check if the video is working or not. Yeah, it's working properly fine. Yeah, it's working properly fine. Okay. Since we have to find, now we have to find the internal forces at point C. What we do? When I make you understand the internal forces, what we are doing, we are cutting the section, right? We are cutting the section. So we will either take left hand side, either take right hand side. It's your choice. You can take any one side. Suppose if I take this one, I will take the section over here, right? In question we say to find the internal forces to section C, so must we have to take the section and C, right? And we have to understand this is a determinate structure. This is a determinate structure, so we are doing like this. What if in case this is an indeterminate structure? Then there is a different thing. Then in order to find the support reaction, you have to use another technique, which I am going to provide you in the next video, which is the question is related to like this. Okay. So take a left hand side. Here we take right hand side. Since we take left beam, we take like this. Right, and there is a point C. So since we are taking left hand side, there is BC, right? Shear force. There are three forces. One is NC. Since see, what will be NC? Since there are no horizontal forces, is there any horizontal forces? No. So NC equals to 0 directly. Why 0? Because there are no any horizontal forces. And there will be a what? Moment. Moment, since we are taking left side, the moment will be like this. So this is MC. So we already found a normal force. See, axial normal force n equals to 0. We have to find BC and MC. Since we got VA, we have the UDL over here. It's imperial distance over here. We have a UDL over here, 40 kilonewton. Okay, 40 kilonewton. From here to here, we have 1 meter distance. 1 meter from, so we have one here, BA. BA equals to, what is BA? BA equals to 50 kilometer. 50 kilometer. From here to here, the distance is 2 meter. From here to here, the distance is 2 meter. So, you see? Okay. We have to find BC, right? What we can use? We can use equilibrium condition, right? Since we know all this one force, we can easily find BC. What we gonna do? We can take this one. F of y equals to 0. Since this one is coming downward, since minus 40, so that's a minus 40. This is going upward, so plus 50. BC is also going downward. What is that? BC, right? BC, yeah, plus 50 equals to what? 0. So minus plus, that will be 10 kilonewton and that will be BC. So what is the BC? BC equals to 10 kilometer. We find the BC, we find the normal axial force, shear force, normal force. So what is one left? The one is left, the bending moment. Right, the one is left is here, the moment, right? So that's why I told you this. You see, this moment is which direction? This is anti-clockwise, clockwise. Right? You have to understand those things. Okay. So we find BC. We will write over here. BC equals to 10 kilonewton. What we got? NC equals to 0 kilonewton. Right? Now we have to find MC. MC equals to. Okay. We're going to erase this one. Since now we have to find the moment MC over here, right? What we can do, we can take a moment, right? At which position? At which position you like to take the moment? Like to take the moment here, like to take the moment here, or you like to take the moment here? You can take moment anywhere, no problem. But what I told you, where you have to take the moment. Always take a moment where two forces getting cancelled out. Here is one force, here is one force, or more than two forces. There are two forces, right? This direction is here, and this is here, yeah. So there are two forces, right? But here the MC is 0, so you can take anywhere, no problem. But I would like to take this point C, right? Yeah. So I would like to take the moment here, moment at C. What I will do, you will do here. I will take moment at C equals to 0. Since I will take the moment at C equals to 0, there will be no BC, there will be no NC. Why? Because there are no perpendicular force. What is the moment? Moment equals to force into perpendicular distance. Since there is no any perpendicular distance on BC or NC, there will be the forces will be cancelled out over here, right? So there will be only moment from here and from here. And what is this one? Particularly, what is this one? This is anti-clockwise. What is this VA? VA, what is this? This is clockwise. What is this MC? Anti-clockwise, right? Yeah. So we take the moment at C equals to 0. Then what is this? There is a moment at M. At C. What is that? MC. What is the direction of MC? Since it's a moment, we don't have to multiply with the distance. It's only a moment. So at C, what is the distance? See, it's a anti-clockwise. So that will be plus MC. Okay. Plus MC. Okay. Plus MC. Then if we take from here, this is, what is this? This is also anti-clockwise, minus 40, right? See? I'm sorry, this is also anti-clockwise, this is also anti-clockwise, right? This 40. So what is this? The distance from here, there is a perpendicular distance from here to the right. So the distance is 2 and 1, 3, that is plus 40 into 3. Plus 40 into 3. Since this is the 50 kilonewton, what is this? You see? This will go like this. What is this? This is clockwise, right? And we do have perpendicular distance over it. What is this? 2. So minus 50 into 2. What is this? Equals to 0. Since we have to find MC, right? What is 40 into 3? 40, a C, not this side. This is plus 120 and minus 100 equals to 0, right? We take this one equals to 0. See? So if we take, find MC, what is this? So MC equals to 120 minus 100, that will be plus 20 equals to 0. So MC equals to minus 20 kilonewton per meter. See? So what we get, moment at C equals to minus 20 kilonewton per meter. So for the direction, since we got a minus over here, right? What means minus? Minus means clockwise. So what the direction we take over here, anti-clockwise, is actually not valid. So we can take the direction like this, MC. MC, we can take direction like this, MC. So if we take MC, so here will be minus MC equals to minus 20 minus what out, MC equals to 20 kilo. MC equals to 20 kilonewton per meter. So in the final answer, it does not matter. We just have to find here internal forces. The question did not say we have to consider the sign formula, but we can either write here 20 kilonewton, either write minus 20 kilonewton per meter, or either write 20 kilonewton per meter. Both is okay, no problem. And this is our final answer for this question. Hope you guys like this video. And at last, what I want to tell you that please subscribe, please subscribe my channel and watch the full video. I'm not going to tell you share, but if your friend is struggling with those things, please share this video to your friends, and please subscribe, and please watch this full video from initial to the end of this video. Then you're going to understand all the concept of this question. Hope you like this video. Thank you so much, guys.